Hey folks, Quill18 here, and welcome to another episode of our C# tutorial for complete beginners. So far, we've been working on a bit of a number guessing game, and in doing so, we've learned a little bit about variables, integers, and strings. We've learned a little bit about conditional statements, if, and else. We learned a little bit about looping with the while and do-while loop, but honestly, I'm not very keen on that particular way that I explained it, so we're going to be taking another look at loops, as well as introducing for loops and for each loops relatively soon. We looked a little bit about converting numbers with this try-catch statement, but we're really not going to go into that too much. Basically, other than saying this is a way for us to catch some errors, but I definitely encourage you to do some more research on this. Try and catch and exceptions and throwing exceptions are really powerful mechanics, but we're mostly going to gloss over anything more than just wrapping our little parse statement in there. And yes, we have this little guessing game. The problem is so far that right now, while it works great, if we give it a run, what am I thinking? I'm going to guess you're thinking a 7. No, my number is smaller than that. Okay, what about 3? No, my number is larger than that. How about 4? 4 is correct, and in fact, 4 is always correct, because we have 4 hard-coded in here. We are not yet generating a random number, which is ideally what we would like to have happen. Now, it turns out computers are really bad at doing things randomly. Computers are actually very sequential and logical. 1, then 2, then 3, then 4. That's the order that things shall happen. To ask a computer to make a random number is actually basically impossible. Luckily, math kind of solves the day for us. There's nothing built into C# that generates a random number exactly, but the default system library here, Sparta.net, does include a set of functions to generate pseudo-random numbers, which are random enough. Basically, they get seeded with an initial number. That's quite large. It could be like 1,750,000,000, da 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 da. So some random number gets generated in there as the seed. In fact, usually you use the current number of, milliseconds that the computer's been turned on or something of that nature to start things. And there's a math equation that you can, from this seed, you can generate a number, and then you can generate another number, and another number, and another number. And if you just look at the series of numbers that gets generated, they appear to be perfectly random. They appear to be evenly distributed across the range that you're looking for. For example, if we're looking for a number between 1 and 10, we should see all the numbers from 1 to 10 appear and relatively distributed. But it's kind of faked. Anyway, the reason I bring that up is because the way in C# that we generate random numbers requires us to take a couple steps that you might not be expecting. You actually have to instantiate an instance of the random class. So we haven't talked about classes yet, and that's what this episode is going to focus on. When we started off in the first part, there was a little bit of magic. Basically, these lines over here were sort of quasi-magic. Again, I said, we are importing a library of standard functions. Namespaces don't really do anything. They just help to segregate our code from other code. That's good. And then we get to the class. So a class is a way to describe, well, I guess a class of objects. One of the examples that I always learned, when I was doing my C++ for dummies like 25 years ago, a good way to introduce the idea of what a class is assume you've got, say, a class that describes ovens. Okay? This class says that an oven has a height, width, and depth. An oven can be set to a certain temperature, and an oven can be turned on or off. These are traits that all ovens have. And then what you can do is you can instantiate a specific instance of a class. It would be an object of that class. So in my kitchen, I have an instance of the oven class. I have my own object of this oven class. I can set my oven to whatever temperature I want. I can turn it on and off. Then the restaurant down the street from my house, it itself has 3 instances of the oven class. And so these instances are in the physical world, they would be physical objects. And each one of them can be set to their own settings. If I turn my oven on, it doesn't turn on all the ovens at the restaurant. And each one of us can have our temperature set to different places. But because they're all instances of the same class, the same oven class, they share characteristics. Classes can be thought of a bit like a template, for example. Well, the random class allows us, it's designed to generate random numbers. That's its jobs. An oven cooks food, the random class generates random numbers for us. But before we use it, we have to instantiate it. Now you may wonder, like, why isn't the main class being instantiated and different things like that? This one's kind of special and has to do with the static keyword over here, and we'll look more at that a little bit later. So we want to generate a random number, which means we need to instantiate the random class. So this is a type of object. We're gonna keep a copy of this. Okay, we're gonna keep a copy of this random class in a variable. The type of the variable, instead of being an integer or instead of being a string, it's going to be a variable of type random. And we're going to call it, I don't know, random lowercase, like this. Again, spelling matters. So this, okay, that's fine. It's great because it's a local variable that hasn't been used. That's fine. So random with the small r is going to be the name of our variable. Random with the capital R, that's our class. And again, you can look up this information on the MSDN. Just Google C# random, and it should bring up the reference to this. And that's going to be fine. So this is our variable. We have declared our variable, but we haven't assigned anything to it, right? Right now, this is, well, what is the value of random right now? It's kind of an interesting question. For some types of variables, for example, an integer, some int, if we don't assign any value to it, it sort of technically has a 0 in it, except not really, and it depends on what programming language, what the default value of this integer is. It's kind of a fuzzy-wuzzy thing. If you were to try to use this without instantiating it, you would likely get a complaint from your compiler, okay? Which is kind of funny because, and this is a bit of an aside, if you instantiate an array of integers, which we're not going to talk about arrays yet, but I'm just sort of doing an aside for the more advanced people. If you instantiate an array of integers, and then you're perfectly fine referencing an element of the array, and it'll just have a value of 0. But if you were just trying to use a single integer, then you would typically get an error because it hasn't been assigned, which is good. That sidetrack aside, it means you generally can't use a number, can't use a variable until you've assigned something to it, because whether it has an internal value or not, the compiler is telling you, you probably don't want to just assume. So if you want this to start at 0, just set it to 0. But all that to say, so we have declared a variable called random of type random, but right now it is null. That's actually the default value of an unassigned variable that is normally a class. Right, integers are a little bit funny, but this is null. And null is a type we haven't actually talked about. But null is a value that means it's nothingness. It doesn't point to an instantiated object in any way. And if we were to try to make use of random at this point, we would get an error. In fact, I'll show you how to use random at this point. The way we do it, so our answer over here equals 4. We were hard coding it. Instead, we want to say random.next. We want to get the next random number in this sequence. Now, this is an example of a function that belongs to an object. Now, we've been messing with this console class before. We were able to call console.writeLine and console.readLine without doing anything special with console because these are static functions. Again, we're going to talk more about static functions in a bit, but console.writeLine we could call without instantiating console because it's static. Whereas random.next, the .next part of the random class, you can't do it directly. I couldn't do this, for example. Capital R random, which is the class itself, I can't use capital R random.next because this is not a static method that belongs to the entirety of the class random. Instead, it's a method that belongs to an instance of an object. You need an instance of random before you can call .next on it. Now, if I try to run this, I will get an error. So let's see it. I'm going to hit build, or rather run, building, and there we go. We get a nice, lovely error, and it says unhandled exception, system.null reference exception. Object reference not set to an instance of an object. And it tells me what line it happened in. What it's saying is I'm trying to use a method that's supposed to belong to an instance of an object, but this object doesn't exist. It's just null. It points nowhere to no memory. It doesn't do anything. So what we have to do is actually create a new instance of random. This is very different. There's a big difference between having a variable. This is a variable called lowercase r, random. Okay, there's a variable that is defined that this variable is a placeholder. This is a drawer that can hold a random. But right now that drawer is empty. So we need to fill the drawer, and we need to create a new instance of random. This is how you create a new object. You don't tend to have to do this with integers and strings because the way you create them is a little bit different. Well, because mostly you're just saying, you know, so this is an int called I, which we're setting to 0. This is a string s, which we are setting to blah, 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 blah. These have sort of values here. Whereas everything else, I mean, I can't just say, there's no way for me to say int random is equal to, what is this? Well, it's not a number. This is not an integer. It's not a string. Like, that doesn't make any sense. I have to make a new instance of random, and I do it this way. Now, this should look to you like a little bit of a function. When you see these parentheses, this should imply that there's a function here. When you create a new instance of a class, you are going to be calling something called a constructor. We're going to look at that in a moment. But the important point is you can pass certain parameters to some objects or some classes when you instantiate them. In this case, random has a default empty constructor. It's perfectly happy to take no arguments whatsoever. But if you'll notice over here, see it says 1 of 2 again. If I hit the down arrow key on my computer, I can see the other variant, the other overloaded constructor here, which could take a random, a number, an integer as our seed. And what's kind of interesting about that is if I feed in some number as a seed here, that will mean that we'll get a pseudo-random sequence. Whenever we ask for a random number, we'll get something that looks random, and then another number that looks random, and another number that looks random. But the next time I run the program, so if I put, you know, some number in here, the next time, that's too big. Next time I run the program, I will get exactly the same sequence of seemingly random numbers. So again, if we're asking for something between 1 and 10, the first time I run it, it'll go 3, 8, 2, 6. But the next time I run it, it'll be exactly the same, 3, 8, 2, 6, so not truly random. If you leave it empty, then by default what it's going to do, it's going to seed it with the system clock. This random function, this random class, is actually not that critical, so I feel bad about explaining so many things, but I think it sort of goes along the way about, like, explain a little about how computers like to think. They don't really think the way that you and I think, and that's a good example of that. Anyway, so we instantiate a new instance of the random class, and now what we can do is we can say, give me the next number. Give me your next random number. And if you just keep calling random.next, you'll get a whole series of random numbers. Now, by default, random.next, what number does it bring up? Well, let's find out. Let's try to run this and see. So it's saying I'm thinking of a number between 1 and 10. I don't think that's true. What's my guess? I'm going to guess 10. Oh, my number's larger than that. How about 100? No? 1,000? 10,000? Let's go right up to 1 million. Bigger than 1 million. 100 million? It's larger than that. Oh, and I accidentally overflowed by typing in a number that was too big for processing at the number. Oops. So whatever it was thinking of something very, very big. I could have had it print out, for example. But the reason it's thinking of a number that's very, very big is because by default, random.next gives you a random number between 0 and the biggest possible integer that the computer can handle. And that's a big number. It's going to be in the billions, depending on, you know, architecture and bits and things like that. But it's going to be in the billions. Well, we don't want a number between 0 and 1 billion. We want a number between 1 and 10. Well, there's 2 ways we can fix that. First of all, we could take the number that is returned here, and we could use this modulo or modulus or mod operator over here. And what this is it divides. It takes this number, divides it by 10, and returns the remainder, right? So if this happened to generate the number 17, 17 divided by 10 is equal to 1 with a remainder of 7. If you remember really early division, right? Before you got into decimal points. So if this returned 17, this whole thing would return 7, which is great. But what it's actually doing here, it's not going to return a number between 1 and 10. It's going to return a number between 0 and 9. And the reason for that is, let's say random.next actually returned 10. 10 divided by 10 is 1 with a remainder of 0. So this would return 0. So it'll always return somewhere between 0 and 9. So what we could do, if we actually wanted to be between 1 and 10, as opposed to 0 to 9, we can do this, and then add 1. Because of the order of precedence, this will correctly give us a number from 1 to 10, although for clarity, it really helps if you put extra parentheses in here. Technically, you don't need these parentheses, but it sure as hell makes it a lot easier to read what's going to happen here. So we're going to take this, divide it by 10, get the remainder, add 1 to it, which means answer will always contain something between 1 and 10. And we could run this and see. So I'm going to guess 5. Oh, ha! Just like that, I got it right. I'm going to try 5 again. Nope, larger number. 7, and I got it right. Clearly, this is working. If we don't want to do this, again, this next function happens to be overloaded. There's actually 3 variants available. There's one of them where you provide a minimum and maximum value. There's one where you just provide a maximum value, which will generate a number between 0 and that value. And there's one where it's blank, where it just generates between 0 and the max possible integer. So we want to use this one. Oh, minimum value, we want 1. Maximum value, we want 10. Except this won't quite do what we're looking for because it's a little bit tricky. And it doesn't really say it in the little pop-up that you're seeing here. It says it in this version. No, it doesn't even explain it here. I'm pretty sure if you look up the documentation for this, the random number that will be generated here will be from this minimum number inclusively to this maximum number exclusively, which means this will only return numbers from 1 to 9 as opposed to 1 to 10. So I believe you need to do this, although I might be lying to you. Check the documentation to make sure. But the reason for that is very tightly related to the math example that we did just before this. Anyway, so what we're doing here is we've instantiated this new object and we're using it to generate a random number. Awesome. Good. Exciting. Probably not all that clear to you. To make this more clear, we're going to go and create our own class for our own game that we're going to do, and I think that will make things a lot more clear. Now, what I'm going to do here is I'm actually going to start a new project. I'm going to leave this in here because in theory, this should be perfectly functional. I'm going to upload this as is, and you guys can play around with it. All right, so we're going to take what we've learned here and create a new solution that applies that stuff and also explains a little bit more about the magic that was going on here before. Although we've explained it a couple times, we're going to reiterate it because it's one of those things that, because it's kind of magic, it can be a little hard to keep in the top of your head. So we're going to create a new project. So we went new file, solution, actually, new solution, which holds a project within it. And again, we're going to go down to other and .NET, but instead of choosing console project this time, which is what we did last time, I'm going to start with an empty project so that we can sort of explain more of the little bits as we go on. So we're going to create a new game. We're going to call it Dodge Game over here. Now, it is worth noting, we could clarify things, that this is the Dodge Game solution as opposed to the Dodge Game project. So you can do this, and you can see exactly the folder structure that gets generated. And honestly, this might make your life a little bit simpler and a little bit clearer because you don't just see the same thing repeated more than once. But you don't actually have to do that. Anyway, I'm going to go ahead and hit create. And what we end up with is a completely empty project. We have a solution that's got a project called Dodge Game in it, and it has no files whatsoever. It's completely empty. So if we were to try to compile this right now, we would get an error. If we go build all, we get an error here, and it says program does not contain a static main method suitable for an entry point. What's all that about? Well, when you run your program, somehow the program has to know where in your code to start. Now, in the olden days, when you'd write, say, a basic program, it was easy. It started at, you'd have one file, it would start at the top of the file and work its way down. That was basically it. But now you have this executable that can be comprised of multiple code files. On your average project, you're going to have, 10, dozens, maybe over 100 different code files. And somehow the executable needs to know in all these code files, where do I start? And the way it determines that is it looks for a static method named main in some kind of class somewhere. And by convention, but also because it's a really good idea to keep your classes as simple and as focused as possible, you will typically have one file that contains one class that simply contains one method called main, and its entire purpose is to be the entry point into your program. Every piece of code, every part of your program, every piece of code that runs exist within a function, and in a heavily object-oriented language like C#, also like Java, for example, every function has to exist within a class. There's no such thing as a function that exists outside of a class in these very heavily object-oriented programming. In C++, you can have functions. In fact, you do have functions that exist outside of classes because C++ is almost sort of like just a layer on top of C, which was not object-oriented, which means there was no such thing as classes, which means every function just sort of existed globally in a way that is not a great way to program these days. Anyway, we're going to start off here by going to the Dodge Game project, not the solution, but the project here, and we're going to add a new file to this. Now, almost 100% of the time when you do this, you'd probably be adding, say, an empty class. And what this will do is it will automatically put in some lines of text in there for you. It's got a bit of a template. Very simple, but it does things that you're basically going to want to do 99% of the time. We, however, are going to go with an empty file instead. So we're going to create an empty file, and what I'm going to do is I'm going to call this Dodge Game main.cs. The .cs is important because it says that it's a C# file, so that Xamarin Studio here, MonoDevelop, knows how to color all your syntax and also how to feed it correctly into the compiler to make it executable. But the first part isn't quite as important. It can basically be anything you want. In C#, as a convention, you name your file the same name as the class. This might be a lie. I don't believe it requires the two to be the same. Whereas I think in Java, I think it does. However, I may be lying to you in both ways here. In any case, 100% of the time, you're going to want to name the file the same as a class, because if nothing else, it makes things way, way more organized. So we're going to go ahead and create Dodge Game main.cs. This is an empty file. It's a completely empty file over here, and we can start typing. Now, we're basically going to repeat some of those magic lines from the last project, but this time with some context. First of all, for example, using system. And again, normally you would click on this and you would add new class, and it would do this little bit for you. We're going to include system because we need the standard .NET library for many things, including, say, the console, for example. Then we're going to include a namespace. Now, if you program in Unity, when you create a new file, a new component in Unity, which is a class, it won't include a namespace declaration. And you don't, I guess, strictly need them, but what it does is it keeps your program well organized. Again, my example before was if you have in your project, a class called player to hold information about your player, and then you import some sort of, say, a sound library, and it's got a class called player as in a music player, there could be a conflict there. However, because each of us are going to have all of our code within our own individual namespace, no more conflict. So everything within this block will be within this Dodge Game namespace. And it's just basically, namespace is just a way of organizing your code. It doesn't really do much. And then we need a class, because again, everything in C# has to exist within a class. So we're going to create a class, and because we're going to name it the same as the file that we're in, we're going to call it the Dodge Game main class over here. Good. There's a little bit more syntactical sugar that you could put around Dodge Game here. Well, it's not necessarily sugar, because sugar implies maybe stuff that doesn't do anything. We could make this static. We could make this public. I don't think we need to for this, so we're not going to, so that way we can talk about those things a bit more later on. But now, we need something that will actually run. And if we were to try, again, if we were to try to compile at this point, do a build, we still get an error because we still don't have a static main method. So we need to create our first method or function. I use those terms intermittently here. A method is basically a function that belongs to a class. So that's why I'll use the terms interchangeably, even though some people in the strict circles make a difference between the two. But we need a static method called main. Well, let's back up. Let's just make our first method or our first function here. So first of all, it needs a name. So we're going to call this main because we know that's what is going to be required. Then there's two more parts to a function definition that's required. It needs parentheses. Whoops. Thank you, autocomplete. That's not at all what I was looking to do. It needs parentheses here. This implies or indicates that it's a function, but also what it does is in parentheses, you would be able to list any parameters that this function requires. We have passed parameters to functions before. For example, console.writeLine, we passed it a string because it requires a string, because in its definition, it says in here that it wants, some sort of string, I don't know, called value or something like that. It requires that you pass it a string. We're going to leave that blank for now. The other thing that a function needs is it needs to define what it returns. Some functions return things. For example, console.readLine reads input from the console and then returns a string. Random.next returns an integer. Some things don't return anything. For example, console.writeLine doesn't return anything. It just writes stuff to the console, but it doesn't actually return anything to your main program. This main function is one of those. It doesn't return anything, so we declare its return type to be void. Void means this function literally returns nothing at all. It doesn't return a null. It doesn't do anything. If you try to assign the output of main into a variable, you will get an error because main literally returns nothing whatsoever. Then again, we open a new block. So now we have a function called main. But again, if we try to compile this, so I just hit F8 here, we still say it doesn't contain a static main method. So what's the difference? What does the static thing means? Well, static in front of a method means that the difference between this function belongs to a class directly versus without having static, this belongs to an instance. With this, you can't call main directly from the Dodge class. Instead, you would need to create a new instance of the Dodge game main, and then you could call main from there. If you recall, and I still have it open over here in Sublime, in my other text editor, it's the difference between being able to call console.writeLine directly. See, we never instantiated console. Console.writeLine is a static method. It's a static method that belongs to console, so we can call this directly. Whereas .next is a non-static. It's an instant method of random, or an object method of random. You need an instantiated object of type random to be able to call random.next. So by putting the static word here, it means we don't need to instantiate a copy of Dodge game main, which is important because as the entrance point of our program, nothing has been instantiated yet. The program, when you double click the exe, needs to just be able to call this function directly without anything having been set up. So now let's try to build and see what happens. Build successful, which to me is always a little bit odd because I always figure, like, shouldn't this stuff need to be public or whatever? Apparently not. But now the build is successful, and we could try to run it, although nothing would happen. We get this application output window over here, which we didn't get before. Why is that? Well, all right, so we just ran it. Let's go and do our console.writeLine. Hello, world. Let's do this again. So we've manually recreated that example. If we were to just create a console project from file, new, solution, as console, we would get this, right? Sorta. Let's run this. And you can see here, application output, hello world. Why am I not getting my dialog box that opens up? Well, one of the other things, and this isn't part of your program code, one of the other things that happens, because if I were to just double click this exe, I would get a console window that like normal. But if I run it from inside of here, if you go to project, okay, project menu, and then not solution options, but rather the options for your project, which is Dodge game options, go down to the run category and general. You'll see these two little checkboxes here, run on external console and pause on console output. This first one means that instead of running the output in that little application output thing down below, it actually opens a console window for you. And secondly, the second one means it'll do that thing when the program stops running, it'll prompt you to hit any key to continue. So if we have both these checkboxes turned on, and now we run the game, we're back to this. So yes, we've had to do some work manually here, but it means we learned a couple of things. Anyway, all right, good. We have a main function that runs. That's great. Now what we want to do is we want to create our first class, because what we're going to do here is we want to have a little player character on the screen that moves somewhere. Well, actually, let's hold off on the class for a second. Let me show you what we're going to do. So our character is going to be represented. Let me get rid of the right line here. Our character is going to be represented by a single character. I'm going to use right instead of right line. The difference between the two, right line puts like an enter after it prints. So it'll, it'll put out whatever we have in here and then return to the next line. So our character is going to be an @ symbol. Very old schooly, roguelike kind of thing to do, represent your character with an @. That's us. So if we run this, oops, ran it the wrong way. There we go. You can see here, because we use right instead of right line, it prints out the @ and then immediately press any key to continue, because there's no new line over here. But that's okay. So it prints our little @ symbol. And then I'm going to introduce you a new function of console. Console.set cursor position. We can use this to set our cursor position somewhere. So I'm going to set this, and this is 0 indexed. If I say 0, 0, this is the top left corner. You can think of this as an offset. This is how off are we from the top left corner. So if I run this, we get exactly the same before. We set the cursor to here, which is where it already was, and we print out the @ symbol. But we can do it more interesting if we do 10, 10, and run that. We are 10 columns over and 10 rows down. It's not rectangular because these letters, this font is not square at all. It's a lot taller than it is wide, so it goes over here. But you can see exactly what happens. We move the cursor, then printed out the @ symbol. Very cool. So what we're going to do is that. And what we want to do is be able to change the character's position. Now, I could give you a little bit of an example with a while loop, and we could use some variables here. For example, I could have an integer with our x position, say set it to 10, another integer with our y position, and say, let's only set that to 5 this time. And we're to set our cursor position to x and y, and run that. Oops, gotta run it this way. There it is. Press any key to continue. This is only 5 lines down, but it looks a lot more square just because of the size of the characters. So there it is. That works out fine. And then we could write some code that modify x and y as we do some key presses. But I'm going to like it a lot better if we can keep our character organized a little bit. So, or I should refer to us as our, let's call it a unit. Excellent. I think that's going to be better. This is the unit that belongs to the player. I'm going to create a new class. So I'm going to right click on my project, click add, new file, and rather than do the empty file, I'll just go ahead and do an empty class. And I will call this class unit. And I'm going to hit new. And so it adds a new unit.cs file into our project. And you can see it adds a few things for us. It includes the using system, because that's very common. It defines that the contents of this are within our namespace. Great, that's excellent, that's what we want. And it creates a new public class unit. Public in this context, we'll probably deal with that a little bit later. But it means that we can... Oh, no, I'm gonna save access until the next tutorial. It also creates this function over here, and you're gonna say, all right, we're talking about public later on, but clearly public's not a type. Public's not like integer or string or anything like that. And didn't I just tell you that every function has to define its return type, right? This is clearly some sort of function called unit that requires no parameters, but what does it return? It's not a void. Right? Again, we're going to ignore public. Public's not the return type. It's not void. In fact, if we define void, we get an error over here. That's because this is not a regular function. This, because it's exactly the same name as the class is unit, this function or method is called unit. This is not actually a method. It's a constructor. What I'm going to do is I'm going to get rid of this for now. We're going to ignore it, pretend it doesn't exist. We're going to talk about constructors and their very, very, very important role soon. And instead what I'm going to do is I'm going to say that this class, again, what I'm doing with this class at this point, this is going to be a real class. It's like our oven. This is going to define the template that all units follow. Not just the player, any unit in the game that we ever spawn will follow this template. So what does it have? Well, it's going to have a position. So we're going to have a variable inside of this called x and another one called y, both integers. That's the current position. And I'm also going to, I'm not going to introduce the car data type, which is a single character. We're just going to go ahead and use string. And the string is going to be my unit graphic. Okay? So these 3 pieces of data are going to define an entire unit. So then what I'm going to do is this. I'm going to go back to my Dodge game main, and instead of defining 2 variables here called x and y, what I want to do is I want to define a new unit. I'm going to call this one player unit. And we know that classes have to be instantiated. So we're going to say we're going to make a new unit. So we're going to create a new unit and save it in a variable called player unit. And then here, for our cursor position, we're going to use the player unit dot x and player unit dot y. Oops, dot y. We will get lots of errors here. And when we write, instead of writing the @ symbol directly, we're going to use player unit dot, what did I call it? Unit graphic, which is just going to be a string. So that's what we're going to spit out. We're going to use the x and y from player unit and the unit graphic, the string, from player unit. But you can see everything is underlined. And if I try to compile this, I'm just going to hit the F8 key. I got lots of errors. It'll be displayed inline by default, and you can click on these things to get some information. Or you can click up here at the build information and get more explicit stuff. What's it saying? It's saying unit.x is inaccessible due to its protection level. Unit.y is inaccessible due to its protection level. Unit.unitGraphic is inaccessible due to its protection level. Also, there's some warnings, but we're going to ignore that. What's going on here is one of the most powerful thing about classes is the idea of encapsulating data in such a way that things outside of the class itself can't mess with it. For example, UnitGraphic here is a string that we are going to write out to the console. But UnitGraphic, because of the way we're going to display things, it's only going to make sense if the unit only takes up one character, right? We're going to use the @ symbol for our character, and we'll use, I don't know, X's for enemies or something like that, okay? Just very simple. But what if instead of using X for enemy, we use the word enemy? Well, then all of a sudden things would look weird and it's not going to be right. And so we would like to enforce that the unit graphic is only a single character in the string. And to do that, you would typically keep unit graphic itself to be private and instead use various accessor functions or properties that people use to communicate with unit. It would represent the unit's interface, which is actually a loaded word that means different things within the concept of C#. But the idea with a class is you can have private data and then you have this sort of public interface. We're going to get more into that next time. For now, what I'm going to do is I'm going to make these. These are fields or variables, member variables. People use different terms depending on language and how old they are when they learned how to program. But these will be fields that belong to unit that are now public, which means that things outside of unit itself can fiddle with these bits. As such, if I try to rebuild this, I get no more errors, and in fact, no more warnings either, because these fields, playerUnit.x, this is public. This is a public part of unit, which means that things outside of unit, for example, this main function, can now access that. Now, if I try to run this, well, nothing would happen. Actually, I believe we'll get an error, because I think unit.graphic will default to null. Let's give it a try. Oh, no, okay, no error. I guess it doesn't default to null, it defaults to an empty string. It just, nothing happens. Why is it? Well, it's because unit graphic is currently blank. Okay, so let's, after we create our player unit, so here we create the new player unit. So instantiate a unit that will represent the player. Set data for this player's unit. So we can go player unit dot unit graphic, and we're going to set that to this string. So now let me try to run this. There we go. We got an @ sign. And then we can set, say, player unit dot x is equal to 10, player unit dot y is equal to 5, and then run this. Oops, use the right hotkey. There we go. Boom. Also, if we don't want this to look so stupid, what I'm going to do is after we're done, so program end down here, just putting a little note, we're going to do some cleanup. And what I want is that push any key to continue. I just want to make sure it appears at the bottom of the window. So what I'm going to do is I'm going to set console. I'm just going to move where the cursor is. dot set cursor, and I'm going to set it to make sure it's at the bottom of the window. So how are we going to do that? Well, the X position is going to be 0. That's fine. We're going to be on the far left. The Y position is the tricky bit. We want the Y position to be the bottommost possible Y position. And we can get that because we can go to console.windowHeight. Console.windowHeight contains the height of the window in characters. So we want to set the cursor to there, but it's important that we do a -1. By default, the window, depending on your terminal settings and console and whatever, is going to be, I don't know, like 24 or 25 characters tall. Let's say it's 24. 24 is how many lines you've got in a window. So if I were just to feed in window height, which would be 24, this wouldn't do exactly what we're doing, because you have to remember this is an offset. The top left corner is 0, 0. So if we set the cursor position to an offset of 24, we'll actually be writing on the 25th line, which will scroll the window in an unappealing way. So I'm going to set a -1 here. And you'll note, again, I'm going to reiterate, white space doesn't matter. So this is fine. Set cursor to bottom most row. Row? Yes, row. Run this. There we go. See, that looks a lot better. Okay. So we've set up this basic player class, this unit class, and we've shown that you can set values inside of that and then print it out this way. We're going to do, and again, we're going to totally change how we access this. But what we're also going to do is we're going to add, to close this out because this has gone on way too long, we're going to add a method to unit. So we've got a class here that's got these 3 public fields, and we're going to also add a public method. So this is going to be a public method. It's going to be void because it returns nothing, and it's going to be called, I don't know, draw. And this is going to be responsible for drawing, this draws the unit on the screen. That's its entire job. And how is it going to do that? Well, it's going to do that with this code here. So we're going to just copy this. I'm going to paste it here. So now we're just going to draw our own X, our own Y, or use that to set the cursor position and use our own unit graphic. Note, I don't have to specify who this belongs to because I'm inside of a class, right? This is a class unit. This is a method that belongs to the class. If I use one of our property names, so we have a property called X, if I refer to that property over here, it will use the X that belongs to us, our instance of it. So this is an instance method. So if we refer to property or fields like X and Y, we will be using the values that belong to this instance and this instance only. So we'll see what that means in just a moment. So we've got this. So what I'm going to do is I'm going to remove this code, which we're using to draw the player, and instead I'm going to call playerUnit.draw. Let's run this. There it is, drawing that character. And what we can do is another example over here. I'm going to grab this and make enemy unit instead. So now we're instantiating a second unit. So then we're going to set data for this enemy's unit. We're going to use, I don't know, capital X for a bad guy. And we're going to put it position 2017, like that. Oops, copy and paste problems. We're using enemy unit, enemy unit, enemy unit, enemy unit, enemy unit.draw. So now we're setting values for the enemy unit here, and then we're telling the enemy unit to draw itself. If we run this, oh, wow, I really screwed up with my copy and paste here. I got rid of the player's draw. Oh, that's right, because I want to do it differently. Hold on. So what we're doing here, let me regroup this. That'll be a lot better. So what I'm going to do is I'm going to instantiate a unit that will represent the player. Now instantiate the enemy. Now draw both units. There we go. Run this. There we go. So this is one unit, and here's another. And we can tell them to draw themselves. We can do a lot more than that once we start adding the idea of AI and other types of functions that will operate on the unit itself. What's nice about this is when you call playerUnit.draw, it means that this draw knows which X and which Y to use. You can actually do it explicitly. So whereas in our program we would do something like playerUnit.x, within our method we can actually explicitly say this X and this Y. In fact, there are some style advocates that specifically say you should always do this for maximum clarity. This is 100% redundant. This .x is exactly the same as just x by itself. We are referring to the x that belongs to this instance. But by saying this .x, we make it really explicit and clear that we mean the one that belongs to this unit, as opposed to another unit. For example, I mean, we could have another function. Let's say we have some sort of function here, some sort of method. Do something to other unit, right? So we have unit other. So this is all of a sudden a function that requires us to pass it another unit. It has one parameter here of type unit, which we will call other. And then I could do something like, so if this .x is less than other .x, then do something, right, of some kind. This .x is less than other .x. That means we're to the left of that other unit, and for some reason that is meaningful. Now again, I don't have to include the this. If I just say if x is less than other .x, then we're doing the same thing. We're comparing the x that belongs to this. But that explicitness is really helpful. How would we call this? We would call this by doing something like player enemy or player unit dot do something to other unit enemy unit. There. So in this example here, when do something to other unit runs, this would refer to player and other would refer to enemy. But we could certainly call it the other way around too. There's no reason I couldn't say enemy unit dot do something to other unit player. Obviously, this is a nothing example. It doesn't do anything, but we will be using this exact construction later on. I'm just trying to sort of sell you on the idea that classes are a really good way to encapsulate that code. That way, units look after themselves. In fact, that becomes even more true if these things aren't public. But that'll have to wait until next time because this has gone on way too long. Thank you very much for watching, folks, and I will see you guys next time. Thank you everyone who continues to make Project Porcupine a reality by supporting us on Patreon. You guys are supporting us through August and early September, and including these mic check supporters, we've got Drazion, Jan Torivel, Julian Auger Lafont, Craig Mortel, Neil Blakey Milner, Ole Peter Talgo, Wes Oldenbeving, Kale the Quick, Valiant Cake Fiend, Aaron Toiveson, Michael McClintock, Marius Fieldvold, Speedy Savant, Jason Yanity, Adjective, Steven Stager, Cupro Panda, Yukofin, and absolutely everyone who's watched, shared, favorited, and subscribed these videos. I appreciate you very, very much.